Okay, so just after Ramadan, we will resume the recordings and all. So as I said, we'll do a few recordings accordingly. So I'll give the recordings by each essay, then each MCQ, then each structure. Still, I didn't get the structure for the 2024 chemistry. So since I'll do what all I have right now, I have MCQs and the essays. So I sent each and every MCQs by one video, so it will be easy for you to get yourself clear and to get the recordings easy here, right? So previously we finished 7 MCQs there, right? And now let's see the 8th MCQ here, right? So in the 8th MCQ, it is a calculation part, right? That we should know. It's easy. It's an this MCQ usually comes commonly in past papers also, but here they have asked in a different manner, right? That's the main thing. Usually they have asked about the concentration, giving the densities and the mass percentage, right? WW percentage of a particular compound, and this is it's the same, right? Okay, here see, I'll give the shortest method here, right? That method is also found to be in an MCQ, right? Without any simplification there. I think it is around like 2019 or 2020 year MCQ actually, like first 20 within first 20 MCQs only these MCQs came. So we'll see. Calculate the WOW percentage of H2SO4. Concentration of H2SO4 is 5.5 mole decimeter minus 3 and density is 1.1 gram centimeter minus 3. So now you have a solution here. In this solution you have H2SO4, right? In this solution they have given the density here, right? So density of H2SO4 is 1.1 gram centimeter minus 3, and then they have given the concentration. So H2SO4 concentration is 5.5 mole decimeter minus 3. Here guys, you should know the question is about W/W percentage of H2SO4, right? So what does this W/W mean? That's the first thing you should know. So in this solution, I just said that there is H2SO4, right? I can accept it because there is H2SO4 in it. So that's why they have given the density and the concentration. So it means the W/W percentage mean out of you should it is a must, okay? Because once you take a particular chemical in a laboratory, they will give within the label they have given the W/W percentage. Like if you take HCl, there will be a W/W percentage in the solution bottle. In the stock solution, you will have. So you should know how much of liquid is needed, how much of water is needed in order to dilute them and form this much amount of this much concentration of this solution, and also that's an important fact here. So you should know what is WW. It means once you take 100 gram of H2SO4, right? In this 100 gram, if you take H2SO4 100 grams here, this solution, this complete mixture solution, in that how many grams of H2SO4 is only present, not the water, right here. Now you should see, if I take H2SO4 only, that means it will be 100 over 100 grams. That means it is going to be 100%, like 100%, right? So that is not possible actually. So you should know, once they give the concentration density here, it's a must to know that there is also water here, right? A solution should have at least some amount of water, right? So within a solution, there must be some amount of water in it. So therefore, once you consider the density is going to be calculated once you know the mass of H2SO4 and the water also, right? You're going to calculate both the masses there, and then you will find out how much of volume you have taken from there. That's how the density has come, right? So in this case, you need to know like how is this possible, right? You here W is going to be 100 gram of that mixer solution. In that, how much of H2SO4 is there? That's the question actually here, right? So it is easy to get it, right? So follow my steps here. You will get it clearly, right? So now I'm going to now I'm going to start with the density here. So it's like I'll do it in a simple grade 10 or grade 11 way, right? It'll be easy for you. Now, if you take 1 centimeter cube, right? I'm taking the density here. If you take 1 centimeter cube, there is going to be 1.1 gram of H2SO4 solution. H2SO4 solution, which means there is going to be both water and H2SO4, right? Keep in mind, once you take 1 centimeter cube of a solution of this above solution, you will get 1.1 gram of H2SO4 solution, which means that solution has both water and H2SO4. So if you take the concentration here, the concentration is going to be in decimeter cube, right? It's going to be in decimeter cube. So you need to convert this to decimeter cube now. So therefore, one decimeter cube has 1000 centimeter cube here, right? Since it is per decimeter cube here and per centimeter cube here, just multiply by 1000, right? If you want, you can separately see the unit conversion here. It will be easy. So then you will find out it's easy that this is going to be the answer. So this is the shortest way. Like if they per centimeter cube and per decimeter cube there, if you want to convert per centimeter cube to decimeter cube here, just multiply by 1000, right? So now, if you once you consider 1 centimeter cube the above solution, you have 1.1 gram of H2SO4 solution, which means you have water and H2SO4 in it. So if it is 1 decimeter cube, then you're going to have 1.1 gram into 1000. So this much of H2SO4 solution is present here, right? So you'll get 1100 grams, right, of H2SO4 solution, right? Now see here, this one's mass, the mass of this particular mass belongs to both water and H2SO4, right? That's the important thing here. This mass is going to be, this mass belongs completely for both H2O and H2SO4. So they have given WOW percentage now. So WOW percentage mean, let's say WOW percentage is going to be X percentage, right? So mass of H2SO4 only in the above solution. In the above solution, right? So you should understand, right? Mass of H2SO4 only in the above solution. So you're going to find out how much of mass is going to be there for the above solution. So they have given H2O and H2O and H2SO4. So I need to find out the mass of H2SO4 only. So 1100 grams into X percentage, right? So 1100 X grams are going to be there for the H2SO4, right? So this much of mass is there for H2SO4, right? Get the point right here, right? So that's what I said. If you take 100 grams of the above solution, if you get the mass of only H2SO4, then you're going to get the WW percentage of this complete solution here, right? So this much of mass there for H2SO4. Now what we can do? Now already you have found out for 1 decimeter cube. So keep in mind you have already found out for 1 decimeter cube. So now we will convert this H2SO4 to moles here. So you should know the relative molecular mass of H2SO4. So H2SO4's molecular mass is like 2 plus 32. So 64 here. 64 plus 32, 96. Then you are going to have 98 gram mole minus 1, right? So here you have 98 gram mole minus 1. Now see, so if you divide this, right? If you divide this, you're going to get the moles here. So moles of H2SO4 in the 1 decimeter cube of the above solution. So W is equal to W or capital M is going to be moles. So N is equal to 1100 gram, 1100 x grams divided by relative molecular mass is going to be 98 gram mole minus 1. So N is equal to 1100 x divided by 98 moles, right? So this much of moles is there in 1 decimeter cube. So in 1 decimeter cube, this much of moles is present for H2SO4. That means that is going to be equal to the concentration for the above solution. They have given the concentration here. Your question is to find the WW percentage of H2SO4. Got it? So this one is going to be equal to here. So in 1 decimeter cube, you are having the this much of moles in 1 decimeter cube of H2SO4 solution. So this is going to be equal to 5.5 mole decimeter minus 3, right? So if you simply N is equal to 1100 gram, 1100 x grams divided by relative molecular mass is going to be 98 gram mole minus 1. So N is equal to 1100 x divided by 98 moles, right? So this much of moles is there in 1 decimeter cube. So in 1 decimeter cube, this much of moles is present for H2SO4. That means that is going to be equal to the concentration for the above solution. They have given the concentration here. Your question is to find the WW percentage of H2SO4. Got it? So this one is going to be equal to here. So in 1 decimeter cube, you are having the this much of moles in 1 decimeter cube of H2SO4 solution. So this is going to be equal to 5.5 mole decimeter minus 3, right? So if you simplify this, x divided by 98 is equal to 5.5. So x is equal to 98 into 5.5 divided by 1100. So if you remove this decimal, it is going to be 1000 here. So 1000. So here 5. So x is equal to 5 it's a 40, 0, 4. But then 5 nines are 45, 46, 47, 48, 49. So 49, 1 decimeter cube. If you find out for the 1 centimeter cube here, you can get the answer quick, right? So it is going to be 1.1 gram x. So 1.1 gram. So here also you're going to have 1.1. Here also you're going to have 1.1. 1.1 here, 1.1. So finally, so x is going to be equal to, x is equal to, if you cancel this, you're going to get 5. So 0.5 into 98. So x is equal to 49 percentage. Right? The mistake I did was like I did for the decimeter cube here. So here they have already given no. If they ask to find out the concentration here, then only you have to convert this to decimeter cube. Since they are given density, it was easy. Right? I did something complex. Sorry guys, so this is the answer here. So answer is going to be x is equal to 49 percentage. So the answer is going to be the fourth one. Fourth one is the answer here, right? If anybody is having any doubts, just drop me a message in the group. So I'll explain it to you again.